6x cubed plus 8x squared plus 24x. X is in common in all three terms, and 2 is in common in all three terms. So if I pull 2x out, I would have 3x squared in the first term. 2x comes out, which would leave me with 4x in the second term. 2x comes out, which would leave me with 12. So we have factored the original trinomial into that part and that part. So now we want to factor 3x squared plus 4x plus 12 further. So if you look at 3x squared plus 4x plus 12, we don't have a 1 in front of x squared, rather it is a 3. So the next question to ask would be, could I pull out a 3 and make that 3 and a 1 right next to x squared so I can factor it easily? Unfortunately, in this problem, we cannot. 3 is not common to 4 and 12. So we've got to do something else. In a problem like this, we take the number without x, multiply it with the number right next to x squared, which would give us 36. Now the process is very similar to what we have done in the past, which is to split and write 36 in terms of factors which would add up to 4. So what are the ways to get 36? 9 times 4 is 36. 3 times 12 is 36. 6 times 6 is 36. And 36 times 1 is 36. You can add, we could also do 18 times 2. Now, you can add 9 and 4 to see if I get 4. 9 plus 4 is 13, so I'm not going to get 4. If I subtract, I'm not going to get 4. Not going to work. 3 and 12, not going to work because 3 plus 12 is 15. 3 minus 12 is minus 9. That won't work. 6 and 6, if you add, you get 12. That won't work. 36 times 1, is that 36? Not work. 18 times 2, 36. That will not work either. So none of those work. So it seems like the term 3x squared plus 4x plus 12 cannot be factored further. So if that is the case, we call that trinomial to be prime. Prime in the sense you cannot factor it in terms of real numbers. You end up having imaginary numbers. Now there is another case where you can factor stuff, but you can't do it via grouping. That is different from saying something that is prime. So in this case, you can't factor at all directly using real numbers. So the factor 3x squared plus 4x plus 12 is prime, and we would leave it as is. So do we have any questions? Here we have 18y cubed plus 6y squared plus 2y. A 2 is in common to all three terms. A y is also in common. If I pull that out, I would have 9y squared plus 3y plus 1. There is nothing in common between 9, 3, and y. But we see that the number right before or right next to y squared is a 9. So we have to multiply 9 with the number 1, that's the last term, to get 3. So 9, I could write it as 3 times 3 or 9 times 1. 3 times 3, when you add, is going to give you 6. And when you subtract it, it would give you 0. Not going to work. 9 times 1 is 9. So 9 plus 1 would be 10. 9 minus 1 would be 8. That's not going to work. So this particular term cannot be factored by grouping, and the answer is what you see. So here we have 3x squared plus 8x plus 4. That's not a 1, so we have to multiply the first coefficient by the last term, which is 4. We get 12. We could split 12, of course, 4 times 3. Other ways would be 12 times 1, 6 times 2. 12 times 1, if you add 12 and 1, you get 13. If you subtract 1 from 12, you get 11. Doesn't match up to 8. 6 plus 2 is 8, so it works. So I could write 3x squared plus 8. The 8, I can split it up as 6 plus 2 times x plus 4. Which would give me 3x squared plus 6x plus 2x plus 4. I have a 3x in common in the first two terms. So if I pull 3x out, I'll be left with x plus 2. If I pull 2 out from the last two terms, I will have x plus 2. So x plus 2, x plus 2. We have x plus 2 in common. So if I pull that out, I'll be left with 3x, plus 2. And that is the factored form. And clearly, this particular trinomial is not prime because we were able to factor it using real numbers. So 6x squared plus 11x plus 4. Since that is a 6, we've got to multiply 6 and 4, which is 24. And we've got to find ways, find the factors to get 24. So I could write it as 12 times 2, 8 times 3. And the next one would be, of course, 6 times 2 times 2, which we don't need. All we need is 2 factors. 12 minus 2 is 10. That wouldn't work. 12 plus 2 is 14. That's not going to work. So that can't be it. 8 plus 3 is 11. 8 minus 3 is 5. Since 8 plus 3 is 11, that is going to work. So I could split that 11 as 3 plus 8, x plus 1. plus 4, 3x squared plus 3x plus 8x plus 4. We have a 3x in common in the first term, which would give me 2x plus 1. In the last two terms, I have a 4 in common. If I pull that out of 8x, I will get 2x plus 1. Now I have a common factor. If I pull that out, I'll leave behind 3x and 4. So the factoring is 2x plus 1 times 3x plus 4. We have a 3 here and 15 there. So 3 times 15 is 45. And we've got to split 45 into two factors other than 3 and 15, which would be 9 and 5. 9 minus 5 is 4, but 9 plus 5 is 14, which is the middle coefficient right next to x. So that is going to work. I'm going to split the 14. So we'll have 9x plus 5x plus 15. In the first two terms, if I pull 3x out, I would have, x plus 3. In the last two terms, I have 5. If I pull that out, I will have x plus 3. X plus 3 is in common. So if I pull x plus 3 out, I would have 3x plus 5. And that would be my final factoring.